We know it takes 12 same-size spheres to build a first closest packed layer around our UME ball. These spheres remember how to burst order out in all directions. In this arrangement, the centers define a 2BBVE with a 6BBVE outside containment field. This video will explore the sphere's relations with the 12-sided rhombic dodecahedron, the R-dodeca. This is a multi-purpose containment field surrounding a sphere or a group of spheres. It is constructed using 12 green sphere diamonds. The long axis of this diamond has a 4-to-1 relationship with the radius of a sphere if it's in a group, and a 2-to-1 if it's a single sphere. Surrounding the 12-around sphere group, the sphere diamond has a long axis of 4BB equals 8 centimeters. These shapes organize the space in between the spheres into symmetrical modular units. This is an example of a physical model of a structural memory. Each individual sphere has its own containment field around it with a long axis of 2BB equals 4 centimeters. This is a fundamental structural numerical constant that defines a potential growth field surrounding any common center. Here the spheres have a radius of BB. To reach the maximum limit of this field, increase the radius of the spheres to 6BB equals 12 centimeters. This becomes a standard growth matrix in our explorations. Let's look in detail at this structural order. The VE has 50 directions from the sphere family. 12 white directions to the corner, 24 yellow to the dividing the edge in half, 8 blue directions to the center of the triangles, and 6 green directions to the center of the squares. In our large potential growth matrix, the 12 white directions organize the spheres by passing through their centers, and the 24 yellow directions define their tangent or kissing point. Here we see the first instance of dividing an edge in 1/3, 2/3 division. We will find that this is a common synergetic division. The 8 blue directions organize the space between the 3-way spherical arrangements, and the 6 green directions do the same for the 4-way spherical arrangements. An effective physical model of a structural memory is how the R-dodeca organizes the space between the spheres into modular units. Design in nature uses economy of means, do more by using less. This 12-around arrangement of R-dodecas is both closest packed and all-space filling, a structural memory connecting spheres to flat symmetrical shapes, an effective source of modular building ideas. At the core of this potential growth matrix is an R-dodeca surrounding our 6BB sphere with a long axis of 6BB as well. There is no limit to how big this growth matrix may become. Everything is connected to everything else. The matrix can double the size of the center R-dodeca to a long axis of 12BB equals 24 centimeters. Or it can remember the 4 circles that define the 6BBVE. The 50-direction communication network and this arrangement of R-dodecas can build any geometrical system relative to its size. Here we will limit our explorations to some of the systems in the sphere family. The large 24BB long axis rhombic dodecahedron surrounds the 4-circle VE that surrounds our central UME ball. The cube with an edge of square root of 2 6BB connects the outer limits of the 8 blue directions defining its corners. That cube can be defined by 2 tetras spinning in opposite directions that interconnect with the 3-layer closest packed spherical arrangement. All of this information exists simultaneously inside this matrix, waiting for a user to define a new building pattern that uses a unique combination of these structural integrities. If we expand our exploration to the full 15 systems of the sphere family, you will see that they're relative to the R-dodeca. The additions are the 2 modular units, the hexagonal prism and the mother mod, and the 7 systems with their corners cut off, the truncated family of systems. We begin with the sphere enclosed by the R-dodeca. The VE has a truncated version relative to the R-dodeca. The VE and the cube symmetrically interconnect as well, with a combination of the cube and octa defining the corners of the R-dodeca. Just let these systems wash over your imagination. They are a source of many modular building patterns that can solve your local building problems.